but so this is 10.1 notes, part B. And we are still solving quadratic equations, but they will look different than they did yesterday. So here is your first example. Okay, so for this equation, first of all, it doesn't look like a quadratic to me. Because what does a quadratic have to have? An exponent of 2. Does this have an exponent of 2? Nowhere that we see. But it is a quadratic. How do we know it's a quadratic, Zach? Good. So I'm going to do this over to the side. You don't have to write this down, but just to prove to you that this is in fact a quadratic, if I multiplied these back, I'd get x squared plus 2x minus 4x minus 8. So x squared minus 2x minus 8. So it is a quadratic. It's just not squared because it's been factored apart, right? So I want us, this over here actually is not going to help you solve this equation at all. I want you guys right now just to guess and check for me and find me the answers. So guess and check what will work for this. Right now you're just guessing and checking. So like you're saying maybe 1 will work. So if I try 1, 1 minus 4 is negative 3. 1 plus 2 is 3. That equals negative 9. Does that equal 0 like it's supposed to? No, so 1's not an answer. So guess and check and see if you can come up with the answers. If you get one, write it down, but don't say it out loud. You can use your calculator if you want to guess and check. So you can, if I want to try 7, I could do 7 minus 4 times 7 plus 2, 27. Close. No, it would not be. Don't tell anybody. Go. It is, yeah, it's the integer, it's not the decimal. is Unit 8. I've ordered stuff. This is 8.1. Yeah. Yes. I mean, yeah, that could be negative, but it's not going to have 2 digits. Got it? All right. Don't say it out loud. All right, write down and we'll see. All right. Those of you who have gotten the answers, let's see, Wade, what'd you get? Tell me one of them. Okay. Zach or Alyssa, what else have you got? Oh, what about 2? Negative 2. All right. So I knew immediately what the answer to this was. Super, super fast. All right. So let me show you how we can look at this, okay? Because this is going to be really important for us to be able to solve. What I was using, and some of you may have also used as well as you thought about it, but if you tried several numbers besides 4 and negative 2, you probably didn't. But we have a property that we learn really, really early on. As early as 3rd grade, you learn it. It's called the zero product property. Okay? And the zero product property is really simple. You all know it, even if you don't, or I hope you all know it. If you don't all know it, go back. The zero product property, you may not know the name of it, but if I ask you, Easton, what 7 times 0 is, you're going to tell me it's 0. Or if I ask you, Katie, what 7 times negative 42, 0 times negative 42 is, you're going to tell me no. 0. And if I ask Peyton what 0 times a million gazillion is, it's still 0, right? So any number times 0 equals 0. It doesn't matter what number you're multiplying by 0. It will give you 0, right? So you learned this in the 3rd grade. It is the most easy of all multiplication tables, right? Yes? Yeah, it is. I think you plugged it in wrong. It's a plus sign right here in that second one. You put it. Oh. If it were a -2, would be the answer. So for these pieces, whenever I have those 2 parentheses right next to each other, they're right up next to each other, so they're multiplied together. So if you get 0 in either one of those parentheses, it's going to give you 0 for the whole thing, right? So what I could think about doing, I'm going to move these down just a little bit so I can show you. So whatever, if x minus 4 equals 0, it's going to give me 0 for the whole thing, right? So if you just, you should be able to do this in your head. Just know that positive 4 minus 4 is going to give you 0. But you could also add that 4 to both sides, so x equals 4. Right here, if x plus 2 equals 0, you subtract that 2 from both sides, x equals -2, right? So either factor, if either factor is 0, then you know that you're going to get 0 as the answer. This is really, really important here. This only works for equals 0. So if it's not equal to 0, you can't use that logic, right? You can't set each one equal to 5, right? There's no 5 product property. Your 5 multiplication tables you had to actually learn, right? But the 0 multiplication tables is just 0 every time, right? Even the kids that never learn their multiplication tables usually can still do their zeros. So let's see how you're doing. Don't say it out loud. Give everybody a second to think about it. I'm going to give you 3 or 4 here that I want you to do on your own. So copy them down and just write your answers down. Don't say them out loud. Give everybody a second to think. Oh, I'm just making them up. And I can tell you all the answers right away. Huh? Right. And once you learn the property well, you should be able to do the same. Well, no. Alright, write these down. Let's see. You got answers. All of these have to be. I mean, it's correct.
So most of the students, or not the students, but this segment be yes and check?
No, but it will always include this at the end of the problem. So we're going to have to factor, so not all the problems will always be factored like that. So we'll have to factor, but this will always be like the last step of every problem, pretty much. Unless it's when you solve all the seeing some success on number 2. Seeing partial success on 3 and 4, but not complete success. So let's talk about them a little bit. All right, so what I'm thinking of is if either part here equals 0, then the whole thing is going to equal 0. Presley, what number is it that's going to give me 0 for that first factor for x minus 1? What number would give you 0 if you plugged it in? 1, right? Because that 1 minus 1, which would give us 0, right? And a lot of times you can just think of it in your head, but if you can't, as we'll see in a minute on some of these harder ones, you can also think of setting it equal to 0. And then you would just add 1 to both sides so you get x equals 1, right? Okay, Passion, what number would give us 0 for that second one? Negative 5. Very good. Again, if you want to, you could do x plus 5 equals 0, and you could subtract 5 from both sides, so you get x equals negative 5. And so both of those are answers. If you plug them in, you can use your calculator to double check. If you plug them in, 1 minus 1 times 1 plus 5 is going to be 0, because that's going to be 0 times 6, which is 0. And then if you do 5, negative 5. Negative 5 minus 1 times negative 5 plus 5. You can check these in your head too. Just type it into shape. You'll get 0. Okay, so you can see it's just really the opposite sign of whatever you're adding or subtracting there for those problems. So questions on 2? All right, for 3, anybody got answers for 3? All right, Owen?
Negative 6.
Okay, I like that.
I think I have another.
All right, negative 6 is good because x plus 6 would be equal to 0. You'd subtract the 6. You get x equals negative 6. That's perfect.
0.
Is also 0. Okay? Because what you're doing here is you're taking each piece. You're taking, this is a factor right here. That greatest common factor is a piece. So you take it, it's multiplied by this. You set it equal to 0. There's no solving that. It's just x equals 0, right? And then the other one, the x plus 6, is going to equal 0. That'd be negative 6. So sometimes you might have a greatest common factor. You're just going to set it equal to 0 and set the other piece equal to 0. All right. Somebody besides Owen have example 4? What you got, Alyssa? All right, negative 3 is correct for one of these because we're thinking about what is going to make x plus 3 0. Subtract that 3, x equals negative 3. And you can do that part in your head. You don't have to write down what I'm writing. It's fine. All right. Who else has the other one besides Owen? All right, Ethan? All right, so if I use negative 5, 2 times negative 5 plus 5, would be negative 10 plus 5, which would be negative 5. Does that give 0? So it's not always just the opposite sign of this whenever we have a number over here. Okay? Jada, what have you got? Okay? So 2 times 2.5 plus 5. 2 times 2.5 would give us 5 plus 5. That would give us 10. But if it was negative, then we would get a 0. Alright, so negative 2.5 would be our answer. Jada, how'd you come up with that? Very good. So sometimes it's a little more difficult to think of in your head, so you could just say 2x plus 5 equals 0. You could subtract 5 from both sides. So then 2x would equal negative 5. And then you could divide by 2. So x equals, sometimes we just leave it negative 5 halves. A lot of the answer keys will just leave it a fraction. Or you can do negative 2.5. Either one is fine. Okay. Correct. Very good. Yeah. Now, when you're really good, you can do this part in your head too, but I think most of us are probably not there yet, maybe a couple of you. Now, these you probably are a lot better at doing it in your head. Okay, so this is the idea. So if you ever see an equation that's already factored, this is what you're going to do. And it has to be equal to what? 0. If I have something like this, x plus 3 times x minus 5 equals 1, you can't solve that. In fact, I don't, unless it'll refactor, I don't think you can solve it all. I'm not going to give you one set up like that. You can't solve it because it's equal to, well, it's equal to 1 here, so you can't use that zero product property. It's not going to be negative 3 and positive 5 for that. So, this only works whenever it's equal to 0. Alright, so let's do another problem. Alright, so we've got x squared plus 3x plus 2 equals 0. Alright, so we could try for a long time to solve that like an equation. And we are not going to get anywhere because we have an x squared and an x. Okay? And so we can't put those together. So if we, like one of the things I can see students wanting to do here, don't write this down because it'd be wrong. But you might well subtract 2 first. Well, then you got x squared plus 3x equals negative 2. And this is wrong. Don't do it. Hold on. I'll explain it. Okay. So that's not going to work. Then, like, if you tried to maybe, like, get rid of an x by dividing it off, you would have x plus 3 over here. But then you have negative 2 over x over here. It's just going to be a mess. You're not going to be able to do it that way, just moving things around and multiplying and dividing. So, Owen, what do you think you need to do? The fancy word for put it in parentheses is factor. Now, we made you factor a bunch because that's what you got to know how to do to solve a quadratic. So you are going to, if everything's not already on one side, you're going to move it to one side, and you're going to factor this. So if I factor this, I'll have an x here and an x here. Owen?
Plus 2 and plus 1.
Plus 2 and plus 1. We could check to make sure that's correct. I'm going to do that over to the side.
I promise you it's right.
I know it's right too, but
I did it right.
I want to clear, make sure everybody's clear here. X squared. Oh, I tried. They may or may not have learned it. So, but you can see that works. You can check it in your head, it's fine, as long as you are being consistently correct on those. If not, you might need to write over to the side, okay? Alright, so I've got it factored. So before we were just factoring, and that would have been our answer. But we're solving equations now, so we need our number answer. Julian, shut your computer for me, please. I need to get some new ones. You guys need to learn how to read a regular clock, just so you're not dumb.
11. You can't read.
Hey, look, we learned this in like 3rd grade. Yeah, 2nd grade.
Yeah.
Yeah, that's what we learned. We had to do it ourselves.
Yeah.
You should learn.
Yeah, you gotta learn that.
They teach 7-year-old kids how to do it over at the elementary school, so I'm pretty sure you can do it.
Hey, what do you mean you don't know what's what?
This small?
You don't know the small one is the hour.
Shorthand's hours.
I can't believe they don't have till 5. It's not hard. The little kids. Oh.
And then it goes by
Obviously not.
five.
And 5
You're just going to have to calm down. All right. So each one of these need to be equal to 0. You can do this part in your head if you want. It's just going to be, you're going to subtract that 2, and you'll get x equals negative 2. And right here, you'll subtract that 1, and x will equal negative 1. So those will be your 2 answers here. Okay. Let's try another. All right, so we got x squared plus 7 equals 8x. Now, I tried to really emphasize, for us to use that 0 product property where we just set each piece, we factor and set each piece equal to 0, what do we have to have as our beginning condition? We have to have it equal to 0, right? Does this equal 0? How could we make it equal 0? We can just move this 8x over to the other side by subtracting it. It is not a like term, right? It doesn't go with any of these, so we just have to write it like this: x squared minus 8x plus 7. You want to put those in order. You want your x squared first, then your x in the middle, then your constant term at the end. And then we are going to factor this. So, Vince, to factor this, I'll have to have an x and an x. What numbers could I use here? Vince? Okay. Positives or negatives? Okay, we need those negatives. So, negative 7, negative 1. Equals 0. And then here, that's not our answer. We got to set each one equal to 0. So x minus 7 equals 0. So x equals positive 7. X minus 1 equals 0. So x equals positive 1. We've got those 2 answers there. Okay, questions? All right, I got a couple more types of problems we need to see before we do some on our own. Alright, so we have 9x squared plus 6x plus 7 equals 5x plus 7. Right, so we need everything on one side. In general, you always want your x squared to be positive, which is already positive. So we'll move everything over here with this x squared. So this 5x, I can subtract my 5x. I'm going to subtract it from the 6x because that's my like terms. I'm also going to subtract this 7, right, so that I can get rid of everything on that on the right-hand side. And once I get rid of everything, what's the number that tells us nothing's there? 0. Okay. Over here on this side, I'm going to have 9x squared. 6 minus 5 is going to give me, 1x. And then, what's positive 7 minus 7? That's 0. I could put a plus 0 there if I want, but I'm not going to because you don't need to. Alright, so I'm going to move my equals 0 over here a little closer to my work. Now, what do I do here? How do I factor that? Alright, this one's just the greatest common factor. It's missing that last term. Both of them have x's. So I'm dividing an x and writing it out front. And Passion, what's going to be left on the inside of the parentheses? When they cancel, what's left? Not a 0. 1. Because x divided by x is going to be 1, just like 5 divided by 5 is 1, 10 divided by 10. Anything divided by itself is 1. So you're going to have that 1 there. Because if you put anything else, if you multiply it back, you won't get the same thing you started with. Okay? So we just took out that greatest common factor. Now we're going to set each one of these equal to 0. So the x just equals 0. That factor that we pulled out equals 0. Well, that is just 0, right? And then we'll have 9x plus 1 equals 0. And we want to solve this here, so we're going to subtract that 1. 9x will equal negative 1, and we'll divide by 9, so x will equal negative 1/9. In general, we'll go with fractions on these. I think that's how I've got the answer key set up. Any questions here? All right, we got a couple more types we need to see. All right, so we got 4x squared minus 25 equals 0. All right. Who has an idea on this one? What do you think? Jada? Okay, so we're factoring, and it's got a special name. It's a difference of squares, right? Because I have that middle term canceling out. So I can do that, and if I check over here to make sure Jada is right, 4x squared plus 10x minus 10x minus 25. Middle terms will cancel. That looks good. So if I do that, then I just have to take each one and set them equal to 0. So I'd add that 5. 2x would equal 5. Divide by 2. So x equals 5 halves, or 2.5. I do the same thing over here. X plus 5 equals 0. So I'd subtract my 5. 2x equals negative 5. Divide by 2. So x would equal negative 5 halves. That is not the only way to solve this problem. It works perfectly fine. It's not the only way. You could have solved that problem yesterday. Okay, this is different than these problems over here because it does not have an x squared and an x. Yesterday, before I taught you anything about factoring, what would you have done to solve that equation? To get that x squared by itself? You would have added the 25. So 4x squared would equal 25. You would divide by 4. So x squared would equal, I'm going to leave that 25 over 4. You can use your calculator. I'm going to show you why. and you would square root both sides. And when you square root both sides, to square root a fraction, you just square it, square at the top and square at the bottom. So it would just be 5 over 2, and I'd have to put a plus or minus with it. So you could still use what we were using yesterday on a problem like that, if you see it. But you don't have to. You could factor as well. Sometimes you might get one that won't factor. If you get one that will not factor, then you would have to solve it like we did yesterday. Some of those we did yesterday, we got decimals and stuff. Those a problem. If I have a problem has an answer like 1.414, like we were getting yesterday, it will not factor. So you'd have to solve it like we were yesterday. So that's just an alternate method there. You don't have to do both. All right, I've got, let's see, one more type I need to see. Actually, a couple more. We're going to do this and one more. Alright, so in order to solve a quadratic, this one is not one we can solve like an equation like the last problem. We got an x and an x squared, so we're going to have to move everything to one side and factor. So probably most of you are thinking to do, subtract that 10 and get -1 minus 2x minus x squared. This is going to be really hard to factor. First of all, our x squared is at the end, and our x squared is also negative. You don't want your x squared to be negative if you can help it. How could I change this so that x squared is not negative? Let's just move everything back over to this side, right? And it's going to make it positive. So that'll make it a positive x squared when you move it over here. Positive 2x and a positive 1. We're going to move everything over. Or you could think you're like multiplying through by -1. That would also work. It's just going to change the sign of everything. All right, Hank, how would we factor this one? Good. So what is our answer for that one, Hank? Good. And then the other answer is also -1, right? So since whenever you do both of these, you're going to get the same thing. You're going to get -1. You don't have to do that twice. So you would just have -1 as your answer. So there are a few of these that are only going to have one answer. All right, let's do one more type of problem, and then we'll let you guys try this on your own. So so we got 4x squared minus 15x minus 20 equals 1 minus 2x squared. Zane, what do we have to do first on these problems? Okay. Peyton, can you help him out? Not quite yet. For that,
Yeah.
it's got to be equal to 0 before we can factor it.
You would move, you do plus 2x to the second,
Good.
and then minus 1.
Minus 1. We'll subtract it from this 20 over here.
Yeah, negative 21, negative 15x, and then 6x to the second. Then you take the parentheses up.
Then it's equal to 0. And then we'll set our parentheses up. So, Zane, every time that we do these problems, it has to equal 0 first before we can do our factoring. So that's going to be our first step, is to move everything to one side. So this one is one of those difficult ones because I've got 6x squared. What could I multiply to get 6x squared? 3x and 2x, and then 6 and 1. Let's go with 3x and 2x. I feel like it's more likely to work. All right. Julian, what could I multiply to get negative 21? Good. What else? Yep. Not negative 3 and positive 7. Then there's another one you can always use. Negative 21 and 1, or we could do negative 1 and 21. All right, so Julian, which one do you want to try? Okay. So negative 21, positive 1. So if we check 6x squared plus 3x minus 42x minus 21. It's not going to work. We could switch them, but it's not going to work. All right, so which one, Julian, now? All right, let's try that. So 6x squared plus 21x minus 6x minus 21. Okay, what does that give us? We got that 21x and the minus 6x. Gives us positive 15x. Is that correct? No. But we're really close because we're trying to get a negative 15x in the middle there. So we just got to switch the signs. So we're going to make this one here positive, and we're going to make that 7 there negative, and that will change our signs and cause us to work. So these problems, what I find a lot of times is students don't finish them because there's so much work involved in trying to get it to factor correctly, but we're not done. Okay, what have we got to do now? Got to set these equal to 0. So 3x plus 3 is going to equal 0, and 2x minus 7 is going to equal 0. So I could subtract my 3. 3x equals negative 3. And divide by 3 to get a negative 1. That actually had a greatest common factor we could have pulled out. I didn't recognize it at first. Could have pulled a 3 out. Over here we'll add our 7. And then we'll divide by 2. So x will equal 7 over 2. The good thing about this is if you forget greatest common factors, you'll still get the right answer as long as you factor correctly. But if we did a greatest common factor there, because that's a good question. Yes. No, we'll probably quiz probably Thursday. Not right now. Alright, so if we divide everything by 3, what we could do, we can divide everything by 3. When you have an equation, you could divide both sides of the equation by that 3. So if you do that, you'll get 2x squared minus 5x minus 7 equals 0. And you don't have to write it out front because you divided both sides of the equation by that, because we're not just factoring there. So it gives you smaller numbers to deal with. So if you notice there's something that you could do that with, you might want to try, because now this would be easier to factor. You would have your minus 7 here and your plus 1 here. It would be a little bit easier to factor because your numbers are smaller. But if you overlook it, you would still get the same answers, because here you still got 2x minus 7, which is the same. Right here you'll get that negative 1. So you'll get the same answers either way. Right. The only thing is if, especially when you have really big numbers, it's helpful to get those numbers down a little smaller so you can deal with them. Okay? All right, questions? All right, so your assignment tonight, this worksheet here has lots of questions on it. And your assignment tonight is going to be to do at least 12. You can do any 12. So if you've got one that you're stuck on and don't want to do, you can skip it and go to a different problem. No, because we're going to work on them tomorrow. So 12 problems here. So go ahead and get started. You guys have a little over 10 minutes. I want everybody working. You can skip around.